Welcome back to Vuln Vibes. In this episode, we are going to talk about a critical vulnerability in Cacti. We're dissecting CVE-2025-66399. This is a high-severity remote code execution flaw, and it's a really interesting one.
It is, and for our audience, the network architects, the security engineers, the blast radius here is just immense.
Right.
Cacti is a cornerstone of network visibility. It sits on your internal network, it often has privileged access, and an RCE on a host like that is a perfect pivot point.
It's a classic case of what happens when data becomes code. But what's so compelling here is that the flaw stems from something so fundamental, a failure in basic input validation. Okay, let's unpack this. So we have to start at the source, right? The SNMP device configuration page in Cacti.
Exactly. The problem begins when an authenticated user, someone with the right permissions, goes to save a device's configuration.
And specifically, this told a community string. This field is just supposed to be a credential, a password, basically.
But the application accepted way more than it should have. And this is where the analysis gets, well, it gets a little disturbing.
How so?
This wasn't some complex logic bug. The source material points directly to the code base where the sanitization was supposed to happen. It was a complete failure in the regex implementation.
A weak regex, I'm guessing. That's not uncommon?
It was worse than weak. It was intentionally deactivated.
What?
Yeah. The advisory notes that the regular expression was, and I'm quoting here, intentionally left empty, disabling validation.
Wait, hold on. Intentionally empty. That's not a bug. That's a feature you'd expect in malware. It suggests a complete breakdown in the code review process.
It does. What's fascinating here is that the security control was just knowingly nullified. It's like putting a deadbolt on a safe and then forgetting to put tumblers in the lock.
So the effect is that these dangerous control characters,
they just pass straight through, specifically the newline character. The application sees it. The validation function is empty, so it just says OK and lets it through unmodified.
And if I, as the authenticated attacker, submit a payload with a URL encoded newline, like a preset, Cacti doesn't strip it, it accepts it.
Accepts it and stores it, verbatim, right into the Cacti database.
So the payload is now persistent. It's just sitting there in our data, waiting for a trigger.
Exactly. The attacker has planted the bomb. The detonation only happens when Cacti actually tries to do its job and pull that device.
Okay, so let's follow that. Now we transition from data storage to code execution. This is where it all goes wrong.
Right. Cacti, it relies on external command line tools to gather metrics. We're talking about things like SNMP or various wrappers around it.
So when Cacti needs to pull the device we just configured,
it pulls that community string from the database, our dirty string, and just drops it right into a shell command template.
And this is where that stored newline character, our little persirene, suddenly becomes the most dangerous thing on the system.
Precisely. In a system shell, a newline character isn't data. It's a command boundary. It tells the shell, okay, that first command is done, here's a brand new one.
Here's where it gets really interesting. You've just executed a shell break. The single command Cacti thought it was running
is now two separate instructions for the operating system. The first is the legitimate but now broken SNMP command.
And the second is whatever malicious instruction you injected after the new line.
The source material gives a great example of the payload. It's a classic multi-line injection. It might start with something benign like public, but then it hits that persero.
And what comes after that?
The attacker's real intent, usually a reverse shell. The payload looks something like bash mash e bash and deftc packref 4444401, all URL encoded, of course.
Of course. So the persero breaks the command, and the embedded bash yi spawns a fully interactive shell connecting back to the attacker. That trailing persero 3 that you sometimes see in these payloads is pretty clever too, isn't it?
It is. It adds another new line and then a hash, which is a comment character in shell scripts.
So it neatly comments out any leftover junk from Cacti's original command, preventing syntax errors that might show up in the logs.
It's all about stealth. And the real kicker, the thing we have to hammer home, is that this malicious command executes with the permissions of the Cacti process user.
Which could be www data, Apache, or something even more privileged if it's misconfigured.
Exactly. So you've gone from editing a device field to potentially high-privilege RCE on a critical internal server.
That immediately changes the threat model. It's not just unauthorized access anymore. It's full system compromise.
And that's just the start. Let's talk about the secondary consequences.
Go on.
An attacker on a Cacti server can do more than just pivot. They can access and modify the monitoring database itself.
Which means they can tamper with the data.
Yes. Think about it. An attacker can mask their own lateral movement by changing network flow logs or modifying alerts so their activity never trips an alarm. They can blind the security operations team.
That's a huge insight. So they don't just own the server, they own the truth that the server reports about the network. The monitoring tool becomes a Trojan horse for data poisoning.
Precisely. Your foundational layer of detection is compromised. It severely impacts any kind of forensic investigation later on.
Okay, so given the severity here, the immediate need is patching. What's the remediation path?
The Cacti dev team was pretty quick on this. The mandatory call to action for every administrator is to upgrade immediately to version 1.2.29.
1.2.29. And that version properly sanitizes the input.
It does. It implements the regex validation to strip out those control characters. No more new lines.
But we both know that patch immediately isn't always possible in large, complex environments. What about interim defenses?
That's a great point. If you're stuck waiting for a maintenance window, you need layered controls. First, lockdown access. This requires an authenticated user with device edit permissions, so tighten up who can actually access that configuration panel.
Makes sense. Restrict the attack surface.
Second, network segmentation. The reverse shell needs to call home. Ensure your Cacti server can't make outbound connections to arbitrary IPs and ports. Block that C2 traffic.
A strong, compensating control. Even if the RCE fires, it can't connect back.
Right. And third, maybe a web application firewall. You could try to write a wave rule to block per0A in that specific parameter, but it's fragile. It's really just a stopgap. The real fix is the upgrade.
So, upgrade to 1.2.29. Prioritize it.
If we connect this to the bigger picture, this whole thing is a stark reminder about trust boundaries. This wasn't a complex overflow. It was a basic failure to clean input, combined with the dependency on legacy shell tools, where a new line means new command.
So what does this all mean for you listening? It means you have to harden your perspective on input validation everywhere. A credential field isn't inherently safer than a user comment box. If your application stores data that will later be passed to a shell, it has to be sterile.
It's a textbook example of why defense in depth is so critical.
It is. But let's leave you with a final provocative thought. We've seen how Cacti's SNMP Community String could be weaponized because of how the system shell interprets a new line. Now consider all of your other infrastructure tools. What other seemingly benign configuration fields, maybe file paths or server names or even environment variables, might also be passed unescaped to some downstream legacy script? What other tools in your stack are just waiting for a maliciously crafted per0A to turn simple data into a command execution exploit? That's the question you should be asking your teams this week.